Welcome everyone, and the topic of discussion is percentage composition. The definition of percentage composition is percentage by mass of each element present in a compound is called as its percentage composition. But the formula of percentage composition is more important as compared to its definition, because all the calculations related to the percentage composition, they are performed by using this formula. The percentage composition is equal to mass of element in 1 mole of compound divided by molar mass of the compound multiplied by 100. This is the formula which will be used in all the calculations related to the percentage composition of any compound. Let us take the first example, and that is percentage composition of glucose. How to find the percentage composition of glucose? Glucose has formula C6H12O6. There are 6 carbon atoms, 12 hydrogen atoms and 6 oxygen atoms in glucose. Now first of all we will calculate the percentage of carbon, but before calculating the percentage of carbon we must have an idea of the molar mass of glucose. How to calculate the molar mass of glucose? As there are 6 carbon atoms, so 12 into 6 plus 1 into 12, that is the part of hydrogen, plus 16 into 6 because there are 6 oxygen atoms, this is the part of the oxygen. And when we sum all these parts, the molar mass comes out to be 180 grams per mole. So percentage of carbon will be equal to mass of carbon over mass of glucose into 100. Now the mass of 6 carbon atoms is 72 divided by molar mass of glucose is 180 into 100, and it will be equal to 40%. Similarly, the percentage of hydrogen is equal to mass of hydrogen, that is 12, over molar mass of glucose 180 into 100, and it will come out to be 6.67%. And the last one, percentage of oxygen. The total mass of oxygen in glucose is 96 grams, so 96 divided by 180, that is the molar mass of glucose multiplied by 100, and it will come out to be 53.33%. We will conclude that glucose has 40% carbon by mass, 6.67% hydrogen by mass, and 53.3% oxygen by mass. This is the percentage composition of glucose. Sometimes the percentage composition of the whole compound is not required. Only one element, the percentage of a single element is required. Just like the second example, calculate the percentage of nitrogen in urea. The formula of urea is shown here. It has 1 carbon atom, 2 nitrogen atoms, 4 hydrogen atoms and 1 oxygen atom. So let us first calculate the molar mass of urea. 12 into 1 carbon plus 14 into 2 nitrogen plus 1 into 4 hydrogen plus 16 into 1 oxygen. And when we sum all these masses, it comes out to be 60 grams per mole, which is the molar mass of urea. Now percentage of nitrogen is equal to mass of nitrogen, because there are 2 nitrogen atoms. Their combined mass will be 28 divided by molar mass of urea, that will be 60 into 100, it is 46.6%. So urea is most commonly used nitrogenous fertilizer in Pakistan, and in this nitrogenous fertilizer the percentage of nitrogen is 46.6%, which is very important for the MCQs. There is another MCQ, that in which of the followings there is maximum percentage by mass. Where is the maximum percentage of nitrogen by mass? In which of the following the maximum percentage by mass of nitrogen? We are to find it. In case of ammonia, which is alpha, there is 1 nitrogen atom weighing 14 gram divided by total mass of ammonia is 17 gram multiplied by 100, and it will come out to be 82.3%. So in ammonia the percentage of nitrogen is 82.3. In hydrazine, there are 2 nitrogen atoms weighing 28 grams divided by total mass of hydrazine is 32 into 100, so it will come out to be 87.5%. In nitric oxide, there is one nitrogen, so weighing 14 divided by whole molar mass of this nitric oxide is 30 into 100 and it will be equal to 46.6%. In the same way, the percentage of nitrogen is calculated in NH2OH, that comes out to be 42.4%. So now in which of the following there is maximum percentage of nitrogen by mass? That is hydrazine. So correct option will be beta. Such kind of MCQs can be solved by common sense without calculations. But I think so that the students must focus on the calculations, because common sense, that is very uncommon, you know. Now, how can we calculate percentage composition of any compound practically? So the practical calculation of the percentage composition is based on the elemental analysis. It is done by the elemental analysis. And one of the example of the elemental analysis is combustion analysis, that we have already discussed, that how combustion analysis is used to find the percentage of carbon, hydrogen and oxygen present in an organic compound. Percentage composition is no doubt a very simple concept, but it is very important one. Why it is very important? Because in order to find the empirical formula of any compound, first of all we have to calculate the percentage composition. So the first step towards the evaluation of empirical formula of any compound is to determine the percentage composition of that compound. That's why it is a simple but very important concept. I hope so that the idea of the percentage composition is clear, and in the next lecture we will come up with the empirical and molecular formula, and we will work how to calculate the empirical and molecular formula of any compound. Till then, Allah Hafiz. Thank you.